Okay, so let us now continue. I will probably skip most of these sequences because I haven't seen any questions from them, but except for this limit, which is important, an important limit, and that is the case. Let me just describe it here for you. So if you have a number, so let me first test your understanding. For example, if I give you the limit of 2 to the n, this limit is a limit of an exponential function, so that the base is a fixed number and the exponent is n. If I ask you what is the limit of this sequence when n goes to infinity, what's your intuition about that?
Infinity.
It's infinity. So what do you say? You say that this sequence diverges to infinity. So what kind of numbers, if I put instead of 2, this will work? So for example, if I want to fix this and make it infinity, what type of x do you put here? Greater than 1. Yes? So if x is greater than 1, then this limit is infinity. And you had the correct intuition. So what do you think about this limit? 1, because all of them are constant or equal to 1. Yes? What do you think about this limit? 0, because this is a number between 0 and 1. When I go higher and higher, then what happens? It becomes smaller and smaller, so it becomes 0. But one thing might be that if I ask you what is this limit, so you see I am replacing this x with 2, your intuition was correct. I replaced it with 1, your intuition was correct. I replaced it with a number between 0 and 1, your intuition was correct. So you don't really need to remember this theorem because you already have the correct intuition in place. And now I'm changing this with all possible numbers that are important here. If I replace it with -1, what is this limit? That does not exist, but this simply diverges. This also diverges, but it diverges to infinity. But this simply diverges. Now I want to test your understanding about this one. What do you think will happen if I have -1/2 to power n? N goes to infinity. This might confuses you a little bit. What is about this one?
0.
This is still 0. Yes, why is that? Because instead of looking at this limit, I can consider the limit of the absolute value. The limit of the absolute value, you have the right intuition, because if I take absolute value, this becomes simply what? 1/2 to power n, and your intuition tells you that this limit is 0. But do you remember I just told you that if the limit of the absolute value is 0, the limit of the sequence itself is also 0. So this is also correct. So more or less, and if I choose a number less than -1, if I choose a number less than -1, what happens? For example, -2 to power n. This diverges simply, but I cannot say diverges to infinity or -infinity because it oscillates. So you already know all the parts of that sequence. You don't need to remember it because your intuition was completely correct. So let us solve one example and then we can immediately go to the next important topic of series. So for what?
There was no break today?
There was a break, yes.
Okay.
Yeah. So evaluate the following limits. So for example, let us choose one of them. For example, the first one. I want to calculate this limit. The limit of 3 to the n plus, what is that? 4 to the n minus 5 to the 2n minus 1 divided by 36 to power n, n goes to infinity. So what is this limit now? Any ideas what to do? Because this is not one of those cases we can switch to functions. I cannot replace it with x. Of course we can. We can do that and use Hobbital's rule. I don't know how many times. Might be it works. But I wouldn't prefer. Actually, this would be the best way to do it. So, any opinion? Yes, please.
You can split with the
A split is the best one. So yes, I would write it as 3 to the n divided by 36 to the n plus 4 to the n divided by 36 to the n plus, minus 5 to the 2n minus 1, and then divided by 36 to power n. And of course you can see what the trick is now. So I can write this as 3 over 36 to power n plus 4 over 36 to power n. But here I have to do some adjustments. For example, I can write it as 5 to the power of minus 1. So let me write it first. So let me write it like this. I would write it as 1 over 5 because of this minus 1 multiplied by 25 to power n divided by 36 to power n. Do you agree with me? Because this one is 5 to power 2n divided by 5 becomes 5 to power 2n minus 1, and I have copied and pasted the denominator. So that's correct. And then I would write it as minus 1 over 5, 25, 36 to 22 power n. And then I send n to infinity. But hopefully you agree, what is the limit of the first one? This number is between 0 and 1, this number is between 0 and 1, this number is also between 0 and 1, all of them are 0, yes? Its limit is 0. What about the next one? Let me do the next one as well. So the limit e to the power of n minus e to power minus n divided by 2e to power n plus 3e to power minus n, n goes to infinity. So in this case we can also use Hobbital's rule, but be careful. Do not write in the exam if you want to apply Hobbital's rule directly here, because when you want to do Hobbital's rule you are taking derivative, and derivative are for functions with continuous variable, not discrete variable. So you have to write it a little bit carefully. But let us use this theorem. If I want to use this theorem, I divide the numerator and denominator by e to the n. This becomes 1. This becomes e to power minus 2n. This becomes 2. This becomes 3e to power minus 2n. I am dividing everything by e to the n. So why this is beneficial, can you see that? For example, I can write it as the limit 1 minus, I can write it as 1 over e to power positive 2n. And the same is true here. But the limit of this one is 0 because 1 over e is a number between 0 and 1. The same is true here. So the answer will be 1 over 2. Okay. Sorry, I have to skip these ones. If we have time, we can come back to it at some point. But I haven't seen questions from these parts in the exam. Let me just jump to this very important topic that you will receive most of the questions from this topic, and that is the infinite series. Okay, so I will go a little bit slower here. So what is the topic of infinite series? You know, because when you want to add numbers, this is the probably simplest thing you learn in mathematics in primary school, to add a bunch of numbers, yes? But adding a finitely many numbers is easy. For example, if I give you 10 numbers, you can add the first two, find the result, and add it to the third one, and then find the result, add it to the fourth one. But if I give you infinitely many numbers to add up, first of all, you should have a definition for what it means to add infinitely many numbers to one another. So informally, we want to add numbers of a sequence, but of an infinite number of sequence. So informally, I want to get a meaning, to give a meaning to this infinite sum. What does it mean if you give me infinitely many numbers? This is possible to give you infinitely many numbers. How? By giving you a sequence. When I give you a sequence, it means I am giving you a list of infinitely many numbers. Then I can ask you, okay, what is the sum of this infinite list? Okay, I have to give a definition first of all. So this is written usually as a sub n. N goes from 1 to infinity. This is the symbol we use, but we have to give a meaning to this. And I want you to learn this definition. The definition is intuitively understandable. but this is the correct definition. So when I give you this infinite series, I can ask you the same type of questions. I can ask you, do you think that this series converges? Do you think that this series diverges? By convergence, I mean, do you think that this sum becomes a finite number? By divergence, do you think that this is not a number, or it goes to infinity or minus infinity? The same terminology that we had before. If I want, this is the definition. If you want to know this, you need to make up a new sequence. This new sequence that I will construct from here is called the sequence of partial sums. What does it mean? It's a very simple one. I give you a sequence, I give you an infinite series, and then you see what is written in front of sigma. You yourself construct a sequence from this sigma. How? The first term is the first term. The second term is not the first term, is not the second term, is the sum of the first two terms. And what is S3? S3 is the sum of the first three terms. All of them are manageable because at each one of them I am adding finitely many numbers, and that is a primary school task to add them. And then I continue this. S number n is the sum of the first n terms. There is a name for this sequence that I constructed here. So I have a new sequence, S1, I have S2, and this list goes to Sn and it continues. So be careful, there is no sigma notation here anymore. I give you the sigma, and then you construct this partial sum, and then you have a sequence you generate. Now this is the definition. If this sequence, then you take the limit of your sequence and send n to infinity. If it turns out to be a number S, then I will go back and say that the series you gave to me converges to S. But if this limit does not exist or diverges to infinity, I would say that this sum diverges to infinity. Is that clear? And by the way, it's a very reasonable definition. Do you agree with me? Because when I take Sn is this sum. If I take the limit of this sum and send to n to infinity, what am I actually practically doing? I am adding how many of them? Infinitely many of them. So it's a reasonable definition. But at the end of the day, it's a definition. So you have to respect the definition. Have you understood the construct? Yes? So let me give you immediately a simple example. This type of questions you should be familiar with. Determine whether... okay, so I have forgotten to... That's a typo. Determine whether the given series converges. If it is convergent, find its sum. Okay? Let me start with a very, very simple one. So, sigma minus 1 to power n, n goes from 1 to infinity. It's an infinite series. So I want to know if this series converges or not. If the answer is yes, I want to find the sum. If the answer is no, I have to justify why it is not. Okay, if you see this, the first duty is to construct a new sequence. That the new sequence is the sequence of partial sums. What does it mean? It means that you construct, so from here, you immediately understand what is your an. An is what is sitting in front of sigma, which is minus 1 to power n. Okay? Now, I am not talking about the convergence of the sequence, I'm talking about the convergence of this series. So it has nothing to do with the limit of this one, apparently. But I have to construct a new sequence, which is called Sn. Sn is the sum of the first n terms. Okay, so let us do that. Sn is a1 plus a2 plus up to an. What is a1? a1 is negative 1. Yes? Plus. What is A2? Is 1. What is A3? Negative 1. And this will go up to the last one. But for the last one, I have to keep n because I don't know if n is even or odd. So I have to write minus 1 to power n. Yes? But is this sum that you see a complicated one or not? It is a very simple one. It has only two options. Yes? So, if n is even, what do you think will happen for Sn? Because these are minus 1, 1, minus 1, 1. If n is even, I can group them in pairs of 2. Yes? So then every pair will be 0. The sum of each pair will be 0. So the total sum will be 0. If n is even. Okay? And then if n is odd, what do you think will happen?
Minus 1.
It will be minus 1. Yes? It will be minus 1. Okay. So this sequence is either 0 or minus 1. Yes? But then I have to ask myself, what is the limit of Sn when n goes to infinity? So what do you think about the limit of Sn? Sn is not a fixed one. So if I want to write Sn, it is easy to write. I write minus 1, 0, minus 1, 0, minus 1, 0. This is Sn. If I ask you what is the limit of this sequence, which I have to answer that limit, what is the answer? Diverges. Why? Because there are two numbers involved here, minus 1 and 0. Infinitely many of them will gather here, and infinitely many of them will gather here. So 0 cannot be the limit, because if I choose an interval around that, infinitely many of them will be outside of that interval. If I choose an interval around minus 1, then infinitely many of them will be outside. So this limit does not exist. Okay, so Sn diverges. Okay? If Sn diverges, I go back and conclude that sigma n goes from 1 to infinity minus 1 to n diverges as well. Yes? Is that correct? Okay. Let us go to the next one. Sigma n goes from 1 to infinity. 1 over n plus. Okay, but let me make it a little bit simpler now. If I want to write Sn, what is Sn? Sn is the sum of the first n terms. I can write it as a sigma again. But I have to, for example, write a sub k. K goes from 1 to n. Do you agree? Okay, so it means that, so you see, whenever you want to talk about convergence and divergence of this, the first duty is to consider this Sn, which is the same sigma, but I am changing the letters. The up one is this index n, and because this cannot be chosen n again, I'm switching to a different letter. Okay? So now, if I want to know about this, how should I know? By the way, this topic is very similar to the improper integrals. You remember, in the first lesson we learned how to calculate the value, but in the other lessons we'll learn that if we cannot calculate the integral, is there any way that I can understand if my integral converges or diverges? That's more or less the same ideas here. So some of them we can calculate. If we can calculate, of course, and if I see that number, that's a number, I can say that my series converges. Okay, these are one of those examples. Again, what is the guide? The guide is that if it converges, find its sum. So it means it is doable. Okay? So the first thing I do, I will write Sn, but I will use the sigma notation from now on. So remember, it becomes sigma. I put this index n up there as the upper limit. Then I change my letter to k, or any letter you like. It starts from 1, and I just copy and paste this one with k instead of n. Let me wait a little bit. Is that understandable? Yes? This is Sn. Or if you are not comfortable, just write it down. If you're not comfortable with that one, you can say Sn is the first one plus the second one up to the nth one. If you're okay with that. So this task is not an easy task. You have to get some actually experience if you are supposed to calculate the sum. The main technique is what is called a telescopic sum. And I will describe what do I mean by a telescopic sum. Okay, but for the time being, if I write 1 over kk plus 1, do you agree that I can write this in this form? Yes, why? Because if I take the common denominator, it will be the same. K plus 1 will go here, k will go here. So k plus 1 minus k is just 1. That's correct. Okay. By the way, what I did here, if you couldn't guess, do you remember the trick?
The A and B.
Yes, method of partial fractions. So this means that I can go here and write it in this form. K goes from 1 to n, and then I have 1 over k minus 1 over k plus 1. You might wonder why this is useful. You need to be patient, you see why this is useful, and from this experience you need to know, this is called the telescopic sum. Do you see that?
Why?
What is the meaning of telescopic sum? Do you know the telescope? So it goes, there's a long, pipe, and then you can just press it and put it in your pocket. So that goes back. You can squeeze it. And that's the same thing. I want you to give the feeling. Why is that? Let us say that you don't know the rule of telescopic sum. What do you want to do? You replace k with 1, you replace k with 2 and continue. So if you replace k with 1, what will happen? It becomes 1 over 1 minus 1 over 2. And then plus, you replace k with 2, so it becomes 1 over 2 minus 1 over 3. Do you agree? And then you go to the next one, you replace k with 3, so it becomes 1 over 3 minus 1 over 4, and then you continue this list. At the very end, you replace k with n, the last one, so it's 1 over n minus 1 over n plus 1. But I want to be a little bit clear here. What will be the previous term? Before reaching to the very end, you choose k to be n minus 1. If you choose put n minus 1 here, I hope that you agree with me, this will be the situation I have. Okay? So you see, this is in front of you. Sn in this form is not easy to calculate, to simplify. But if I manage to write it like this, instead of Sn in this way, instead of writing Sn in this way, I can write Sn in this way. But hopefully you see this is manageable. Why? Because term by term they will cancel out. It's like a telescope. So minus a half from this term will cancel positive 1/2 from the next term. Minus 3/2, minus 1 over 3 from this term will cancel 1 over 3 from the other term. And this cancellation will continue forward. For example, here, this one will cancel that one. What about this one? This is cancelled by the previous one. So all the terms are cancelled except 2 terms. What are those? 1 over 1 is left, and minus 1 over n plus 1 is left. So this means that, could I manage to find Sn? Yes, Sn has a simple form. So I was able to find the sequence of partial sums in a closed form. A closed form means without these 3 dots. Do you agree with this one? Now, I take the limit of this sequence and I will answer the original question based on the behavior of this new sequence. So I take the limit of Sn, n goes to infinity. What will happen? What's the answer? It's 1, because this part 1 over infinity is 0. So then, what should I write as the answer to the question? I would say that yes, this sigma, this series, converges to 1, and 1 is the sum. Is that right? This, let me write this one for you for telescopic sum. So let me write it here for you with a different color. So a telescopic sum, what is the behavior of the telescopic sum? If you have a sigma, inside the sigma you have a function of your counter k minus f of k plus 1. So this means that these counters differ exactly by 1 unit. It doesn't matter which one is bigger, which one is smaller. And say that k goes from little m to little n. Can you guess what will happen if I open this sigma? I want you to train your eye to catch the pattern of a telescopic sum. In a telescopic sum, I need the difference of the same function calculated at 2 consecutive values of the counter. It doesn't matter. It can be k, k minus 1. This can be k plus 1, this can be k. It doesn't matter. This difference is important. The same functions is important, and the counters should differ by 1. Can you guess what will be the sum?
Fn minus Fn plus 1.
Yes, the rule is that put the smaller number in the one with the lower counter, which is f of m, and put the higher value in the one with the higher counter. So it will be minus f of m n plus 1. So that is not very important, you probably can understand, but you have to train your eyes to catch the telescopic sum pattern. Yes? Okay, so let us do one more. This sigma. Sigma of logarithm of what? 1 plus 1 over n, n goes from 1 to infinity. Yes. So how should I do that? So remember, again, compare it with the improper integrals. The first thing we do, we learn how to find the sum. Most of the time, we cannot find the sum. But still, they will ask you if the series converges or diverges. There will be other techniques we learn. Exactly, one comparison method is one of them, but we have more methods here. Okay, but this one that we are learning now is finding the sum. And it is very clear, it is in the problem, okay? If it is convergent, find the sum. Okay, the first thing you do is to construct a new sequence, which is called the sequence of partial sums, and there is a simple recipe for that. Sn is more or less the same sigma, but this n goes to the top, and then I replace the counter from n to some other letter, and I start from the same point here. If it is 2, you start with 2. It's 1, I start with 1. And then what should I write inside? I have to replace n with k. This is the new sequence. It is not an infinite series, I want you to understand. It's the finite sum, and this is a number. So I am making these numbers one by one, so I am constructing a sequence. Okay, but is there any way I can do it? By the way, if they ask you about the sum, it means definitely it should be a telescopic sum. Otherwise, there is no way we can manage the sum. But is this a telescopic sum? The characteristic of telescopic sum needs the difference between two functions. So this will motivate you what to do now. There is no difference here. Yes?
Write it to k plus 1 over k, and then
Very good.
rewrite it into log.
2 logs. So this can be written as log. If I take the common denominator, it becomes k plus 1 over k. Do you agree? And then k goes from 1 to n. Yes? And then there is a formula for log. Log of a fraction is the log of the numerator minus the log of the denominator. K goes from 1 to n. Now, can you see the pattern of telescopic sum appears once more? In the way that I have written, k comes first, k plus 1 comes second, but it doesn't matter. It matters at the end, in the answer, but the pattern is the same. What is my function involved here? The logarithm of x. The logarithm of x with counter k and the different sign and one more for the counter. So, this is a telescopic sum. I have to replace one of these k's with the lower one of these k's with the upper one. Which one with the lower and which one with the upper? The one with more, with the higher counter, I put the higher one. The one with the lower counter, I put the lower one. So this becomes logarithm of what? n plus 1 minus logarithm of what? 1. If you are a little bit, it's hard for you, open up the sigma and you see the terms by term they are gone and these are left. But logarithm of 1 is what? 0. So I was able to find Sn. So Sn is this sequence. Do you agree?
Yes.
And now, take the limit of this new sequence you generated in this way. What is the limit? The limit of logarithm of n plus 1, n goes to infinity. What the answer is? Logarithm of infinity is infinity. So then you have to write it in the correct form. So what do you say about this? The series diverges. You can say more. In that case, just diverges. But in this case, diverges to infinity. Understandable? Okay, I will do the next one as well. Sigma n goes from 1 to infinity, 1 over 3 n minus 2. And then I have 3 n plus 1. Okay. So what should we do now? Sn, the sequence of partial sums, is the same sigma, more or less. Instead of infinity, I will have n, and I change my counter's name, for example, to k, and I replace n with k everywhere. Yes? Okay, but again, I have to manage. If they ask about the sum, it means it should be manageable to find the sum. And there is only one trick you need to think about, and that's the method of telescopic sum. But for a telescopic sum, I need a difference, but this is a product, or is a fraction. So I want to change a product of a fraction to a sum or difference. That's a partial fraction. Even though we learned it for integration, it has nothing to do with integration, but that technique can also be used here. So what I will do, I will write 1 over 3k minus 2 times 3k plus 1. So what, do you remember? I would write plus. I put one of them here, and I will one of them here. What should I write on the top? Should I write ak plus b, or should I just write a? Yeah, because this is just degree of 1, so I have to write one constant up there, another constant here. Can I find these constants? I can probably guess, yes, because this goes there. So I think a should be, this goes here, this goes there, I have to divide by 3, so this one will be, so a becomes 1 over 3, b becomes minus 1 over 3. So let me double check again. Yes, that's correct. So 1 over 3 minus 1 over 3. Yes? And then I put it here. By the way, you know how to do it. You have to multiply it and then equate them term by term and find the system and solve the system and find a and b. That is easy. But if you do that, then instead of this a and that b, I would put 1 over 3 and minus 1 over 3. Then I can factor 1 over 3 out. Yes? So this means that 1 over 3k minus 2, 3k plus 1 can be written as 1 over 3. And then what do I have? I have 1 over 3k minus 2 minus 1 over 3k plus 1. Okay, so this means my Sn is the sigma, k goes from 1 to n of this expression. But because this 1 over 3 is constant, and all of them will share with the same thing, I can pull this 1 over 3 out. It does not depend to my counter, it's a multiplicative constant. But I have to put both of them inside the sigma because both of them depend on my counter. At least, I am a little bit happy because for my telescopic sum, I need the difference of two expressions. Okay? But it doesn't necessarily mean whenever I have this subtraction there, this is a telescopic sum. You have to confirm it's a telescopic sum. Is it? It's a telescopic sum in a little bit disguised form. Why is that? For example, this one is smaller than that one. This is 3k minus 2, this is 3k plus 1. Replace k with k plus 1, from smaller to the bigger. If I replace k to k plus 1, what will happen? This 1 over 3k minus 2 goes to what? 1 over 3k plus 1 minus 2. Do you agree? If I pick this one and I replace k with k plus 1, this fraction will go to this fraction. But do you agree this is the same as the second one? Because 3 times k is 3k, 3 times 1 minus 2 is plus 1. So in principle, this is a telescopic sum. Because if I change k to k plus 1 in the smaller one, I get the bigger one. So what is the function involved? If you want to imagine, this is not needed in the exam. But if I want you to guess about this function, what do you guess? So the function involved is 1 over 3x minus 2. Yes? If this is my function, everyone agrees that this is f of k. And by this analysis, now everyone agrees that this is f of k plus 1. So this is indeed a telescopic sum, even though it was a little bit disguised. Okay, so can you tell me the answer? If that is a telescopic sum, I know what to do. Two terms will survive. In one of them I have to put k1, in one other one I have to put k equals to n. Which one 1, which one n? The one with the smaller value for the counter, the lower value. The one with the higher value of the counter, the upper value. So which one has the lower counter value? This one. So in this one I put 1, in the other one I put n. So 1/3, then I will have 1 over, if I put 1 here, it's just simply 1. So let me write 1 over 1, and minus 1 over 3n plus 1. So finally my Sn is equal to 1 over 3, 1 minus 1 over 3n plus 1. This is the sequence of partial sums. And now I take the limits of this and send n to infinity. So what happens? So the limit of Sn, n goes to infinity, is equal to what? This is 0, 1 over infinity, and then I am get with 1 over 3rd. And then you have, in the exam, you have to write it down clearly that, okay, the sequence, the series converges to 1 over 3, and 1 over 3 is the sum. Is that right? Okay, so this is some trick that you have to know. And this one is a good one. I want to ask your opinion. Decide whether the following statement is true or false and justify your answer. If a sub n equals to 0 for every natural number, the sigma n goes from 1 to infinity of a sub n converges to 0. Do you agree that this is true, or do you think it is false? If it is true, you have to prove it. If it is false, you have to bring a counter example. Of course, in this case, yeah. Which one do you think is the case? Yes?
If you take the limit as n approaches infinity, you then get infinity times 0, so it's indeterminate form.
Okay, but indeterminate form can also be, first of all, this is not indeterminate form. I just want you to understand that. If I have sigma, so do you remember when I say this is indeterminate form, I told you mathematicians are lazy, but this is not 0. If this is the real 0 we learned from primary school, this is not indeterminate. What's the answer?
Yeah.
What's the answer? If this is your real 0, the same 0 as we know, you don't have any money in your pocket, that's 0, okay? So if that is real 0, what happens here? The answer is 0. It becomes indeterminate if 0 is infinitesimal. But this is a sloppy language we use. We say it is 0 times infinity. We mean infinitesimal by a huge number. That is actually indeterminate. But in this case, I have n equals to 0 or 1, 1 to infinity. Everything inside is 0. So how many terms are involved? I have infinitely many terms, but all of them are precisely 0, not infinitesimal. So intuitively, that's not a proof. Intuitively, we guess the answer should be 0. So intuitively, we feel this is true. But how can I really prove it? Intuitive, I want you to feel that this is not 0 times infinity. Do you agree with that? This is definitely, intuitively, we believe this is true. But how can I prove it rigorously? There is only one way, Sn. Don't forget the logic. So you have to construct Sn. Sn is what? Is A1 plus A2 plus up to An. But what is Sn? Can you tell me now? All the terms are 0. So if I add them, it becomes 0. So can you tell me what is the partial sum now? Is a sequence, but all the terms are 0 in Sn. So it means that Sn is the constant sequence constitute of zeros. And if I have 0, 0, 0 as sequence, what is the limit of a sequence of zeros? Is 0. So that is the proof. Okay, so that is correct one. And that is the proof. So whenever you want to say something about the sum of the sequences, the series, you have to go to the definition, nothing else. Some of them are a little bit tricky. Okay, we have a little bit of time. This is a very important series. I want you to remember that. It's harmonic series. It is the sum of the reciprocals of natural numbers. It's a very famous sequence. You will see why it's famous. And it is very important to know that this sequence diverges. It diverges very, very slowly. And by the way, it diverges to infinity. Okay? It's a very, very strange sequence. That's why it deserves a different name. Okay? So, a particular name. So let me just try to see if I can manage to do it in this 5 minutes. So if someone asks you what is the harmonic series, it is the series of the reciprocals of the natural numbers. So sigma, this is this series, 1 over n goes from 0 to infinity. So this 1 plus 1 over 2 plus 1 over 3 plus etc. plus 1 over n, and then of course this list will continue. This is informal way of writing. One thing that you need to know about this series is that this series is divergent, and it diverges to infinity, even though it goes to very, very slowly. I have written something here. If you see, if I have done it, the calculations, I don't remember if I did it myself or I found it from the internet. So if I want to make this sequence go beyond 100, just 100, I want to add these numbers, this will increase incrementally, yes? Every time I am adding a little bit positive number, but a very smaller positive number, yes? If I want to make it over 100, I have to take 10 to the power 43 terms. Okay? But so this is very impossible. It's very strange to think that this can go to infinity. So the increasing rate is so slow that if I want to reach to 100, I have to go to term 10 to the power 43 in order to go beyond 100. Okay? So that's why mathematics, you shouldn't rely so much on your intuition. Okay? So this diverges to infinity. Okay, one thing that we want to learn here, it's a very nice trick. I want you to learn it because I will actually make it more precise next time. So I will consider this function f of x equals to 1 over x. On this interval from 1 to infinity, this function is continuous on that interval, and it is positive and it is decreasing. Okay? So what you have, you can imagine it. I'm talking about this intuitively, but I will make it more precise later. Okay, so what I want to do, so let me pick up this 1, and the next one is 2, the next one is 3, and by the way, this function is f of x equals to 1 over x. And then I go to, for example, n, and then I think we also will need n plus 1 here, okay? So this is the graph, one branch of my function, because if I draw that, I have another branch here, but I don't care about that because I'm considering only natural numbers. So my question for you is this. If I construct a rectangle here, can you tell me what is the area of this rectangle I constructed in that way? The area of this rectangle is the width multiplied by the height. The width is just 1, but can you tell me what's the height? This is 1. If I want to know this height, I feed it into my function. 1 over 1 is also 1, so this height is also 1. If I ask you what is the first area, what is the first area? 1. Is 1. Okay? And now, I go to the next one. I construct another rectangle here. Yes, in this rectangle, what is this width? Is still 1. But what is this height? I put 2 in my function. So this height becomes 1 over 2. And if I ask you what is the area becomes 1 over 2. Do you agree? If I go to the next one, this is 4. This is 1 again, but this height is 1 over 3. Do you agree? And what is the area? The area will be 1 over 3 multiplied by 1, which is 1 over 3. And if I continue this list, what happens to the very last one? Okay, so can you tell me what is the area of the last one? The width is still 1, but what is the height? The height is 1 over. So if I multiply them, it's 1 over. So if I ask you what is this, you will tell me this is the sum of all these areas that you see. But because the function is decreasing, and I have constructed the areas in that way, do you think it will be lower or smaller? Do you think it will be greater or smaller than the area below the curve from 1 to n plus 1? What will it be? It will be greater than the area below the curve from 1 to n plus 1. But the area below the curve from 1 to n plus 1 is an integral. Is an integral of my function from 1 to n plus 1 dx. Yes? Do you agree? So what happens now, this is possible to calculate. Integral is ln of absolute value of x. I calculate it from 1 to n plus 1. And I replace x with n plus 1 and 1. ln of 1 is 0, so this is nothing except ln of is. Do you agree? So, I constructed these rectangles. This is the sum of the areas of these rectangles. Intuitively, it is clear that the areas is bigger than the area below the curve. But the area below the curve from 1 to n plus 1 is the integral of my function from 1 to n plus 1. And what I did, I just simply calculated this integral because it was so easy. And I got this answer. But my question for you is that, what is this compared to here? Do you agree this is nothing except Sn? Yes. Sn is the sum of the first n term. So I was able to show you, hopefully, that Sn is greater than ln of n plus 1 for any choice of n. But my claim is that this will allow me to conclude that Sn diverges to infinity. Do you see why? Because if I increase the right-hand side, if I increase n here on the right-hand side, the limit of this part will be infinity. But every Sn is larger than the corresponding value here. So this limit of Sn should also be infinity. Okay? And then it means that this sigma diverges to infinity by the definition of convergence and divergence of infinite series. This technique I will teach you because many questions in the exam are coming from just learning this technique. Okay? We will talk about this later. Any questions? But this is your memory. Send it to your memory, okay? So this is this diverges to infinity. So can I make this sum bigger than 1 million? Can I do that or not?
Yes.
Yes, because this shows that it is possible, but only God knows how much I have to go forward to make it more than 1 billion, for example. Okay? So be careful. This is a very simple idea. We will make it a little bit rigorous next time. Thank you very much.
Thank you.